Welcome to you all in my YouTube channel Experience Mathematics. Today I am going to discuss about vector and vector geometry. This vector is the important concept in mathematics as well as in physics. Okay, this vector concept is frequently used in mathematics as well as in physical science. So now let's do the introduction of these vectors and vector geometry. Okay, this vector is derived from the word here. Okay, and this is the Latin word. Okay, this here is the Latin word, and its meaning is to carry. Okay, its meaning is to carry. So this vectors is derived from the Latin word to carry, that while carrying also, that while carrying object from one place to another place, it is carried to some certain direction. So the name is this here, to carry. And according to A.N. Whitehead, the idea of vector, that is of directed magnitude is the root idea of physical science. Okay, so according to A.N. Whitehead, the idea of a vector that is of directed magnitude is the root idea of physical science. So directed magnitude means that it has direction, the vector has direction as well as magnitude. So that is the root idea, means main idea of the physical science. So according to Whitehead, we have this definition about the vectors. So now let's discuss about scalars and vectors. Scalars and vectors. The quantities which can be measured are known as physical quantities, and vectors are the physical quantities which have magnitude as well as direction. The physical quantities, which have a magnitude as well as direction are known as vectors. Example of these physical quantities having magnitude as well as direction, they are velocity, acceleration, momentum, force, displacement, etc. Okay, these are the vectors, because these quantities have magnitude, value as well as direction. Now scalars So the scalars are the physical quantities which have magnitude only but no direction. Okay, the physical quantities which have magnitude only but no direction are known as scalars. Example of the scalars are volume, mass, temperature, etc. Okay, these are the scalars. These have magnitude only but no direction. Okay, now the notation and representation. And representation. Okay, so how the vectors are denoted by and how they are represented. Okay, denoted by, represented by. Okay, okay, so vectors are denoted by bold faced type of letters, bold faced type of letters, and this bold faced type of letters are also known as Clarendon letters. Okay, so vectors are denoted by bold faced type of letters, or they are also known as Clarendon letters. And while writing these bold faced type of letters, it is inconvenient. It's like that. To denote a vector, if we have to denote the vector by bold faced type letter, several times we have to write while making it bold. Okay, this bold faced type of letters, this denotes vector, but we have to write several times to make it bold. While in printed form, we can choose that bold type of letters, and easily we can print bold type of letters, but while writing it will be inconvenient. So this is one way of representing the vector. Okay, and so instead of this, vectors will be represented by the letter or combination of two letters of an English alphabet with an arrow over it. Okay, so next way is the vectors are represented by letter or combination of letters with arrow on it. Okay, so vectors are denoted by letter or combination of letters with arrow on it. And here we can denote vector like this way. Vector A or vector AB, okay, like this way. With letter or combination of letters we can denote vector. So here also one the vector A are two letters in boldface type, making it bold. By this way also we can denote, but this boldface type of letters while writing it is convenient, so it is not used while writing. And scalars, in the same way, scalars are denoted by the letter only without arrow on it. Okay, without arrow if we denote, then they are scalars, and they are represented by the directed line segment. Okay, here vectors are represented by line segment with arrow on it. Okay, they are represented by the line segment with arrow on it, and line segment with arrow on it are known as directed line segments. Okay, with arrow on it is known as directed line segment. Okay, so here this is the directed line segment, and here this arrow shows the direction, and length of the line gives us the magnitude. Okay, so in this, here arrow shows direction and length gives us magnitude of the vector. Okay, so arrow is in this direction, so direction is from this point to this point. That means we can suppose this has A and this has B. Its direction is from A to B. Okay, clearly this arrow shows, and this starting point, it is called initial point, or origin. Okay, it is called starting point. Initial starting point is known as the initial point or origin, and it is also called, this can also be called tail. Okay, it is also called tail of the vector, and this one is known as the terminal point. It is known as terminal point or terminus, or it is also known as head of the vector. Okay, so in this directed line segment we have two parts. One is the origin, it is also called initial point or tail. Next one is the terminal point, or it is also called terminus or head of the vector. Okay, okay, in this way we can denote vector, notation of the vectors, and representation of vectors. Both matters we have discussed. Okay, this is the important thing in the beginning of the vectors. And scalars are represented by, scalars are denoted by letter or combination of letters without arrow on it. Okay, so scalars are denoted by letter or combination of letters without arrow on it. So example, this A, B, here we don't have arrow. This denotes scalars, OP, etc. Okay, this denotes scalars. Okay, so in this way I have explained you about notation and representation of the vectors. And now vectors in terms of coordinates. So to explain vector in terms of coordinates, let us take a graph. Okay, and here in vectors in terms of coordinates, vectors in terms of coordinates, vectors in terms of coordinates. So for vector, origin is not necessary to be the origin of the coordinate axis. We can take any point as the origin, and suppose we take this point as the origin. Okay, this point as the origin, and from this, if we go this 10 small division, if we take 1 unit, then 1 2 3 step right, and 1 2 3 4 step up. Okay, we have reached here. Starting from here, we have gone 1 2 3 step right, 1 2 3 4 step up. So this is the vector having its x component 3. So x component, here you can call this as AB of vector AB equals to, we have gone 3 step 3, and y from this 1 to 3 step, we have gone 1 2 3 4 step up. So y component of vector AB equals to 4. So this vector AB is written in this way. AB equals to, we can write like this way also in the form of row 3 4, or we can also write 3 4. So this vector AB is completely described by 3 4. That means its x component is 3, y component is 4. That is AB equals to x, y equals to 3 4. So first of all, just like writing in coordinate, we write x component and then y component. Okay, so in this way, in terms of component, we can represent vector. Similarly, you will see, suppose our starting point is in this space P, and from this we have gone 1 step left and then 3 step down here. Okay, Q. Okay, so 1 step left we have gone, so it is x coordinate is -1, and we have gone 1 2 3 step down, so y coordinate is -3. So PQ vector equals to, we have -1 -3. In this way, we can express vectors in terms of coordinates. Okay, this is the representation of vectors in terms of coordinates. And here in terms of projection also, we can tell this, that here projection of AB on x axis, if you draw here x axis and here y axis, then projection of AB on x axis will be 3 step, and projection of AB on y axis will be 4 step up it will be. Okay, so if you draw here, if we draw here x-axis, and if we draw here y-axis, then this is 3 step here, and this is 4 step up. So projection of AB on x-axis is 3, projection of AB on y-axis is 4. Okay, so this x component means is the projection of vector on x-axis, and this y coordinate means projection of vector on y-axis. Okay, in this way we can write vectors in terms of coordinates. Similarly, if there is the space vector, then using 3 components we can write okay, now the vector OP equals to x, y, z is called the space vector. Okay, in this x component is x, y component is y, and z component is z. Okay, this is known as the space vector. Okay, so for space vectors we can take one box, okay, and suppose here is one box we have, and in this box this is x coordinate, this is y coordinate, and this is vertical one is the z coordinate. Okay, x coordinate, y coordinate, and z coordinate. And if there is one point in the space, then first of all along x coordinate will go, and along y coordinate, and we will go z coordinate up. O, here x, y, and then z, and this is OP vector. It is x, y, z, and along x-axis, x step we have gone, and along y-axis, y step we have gone, and vertically along z-axis, z step up we have gone. Okay, and this a point is x comma 0 0, and this point is x step we have gone here, y step we have gone, so x and y, but z coordinate is 0 in this plates, and at this point x step along x-axis, y step along y-axis, and parallel to axis, and z step up we have gone. Okay, so its coordinate is x, y, and z. It will be like that. So this is the space vector. So in this also similarly, the projection of OP on x-axis is x step, projection of OP on y-axis is y, and projection of OP on z-axis will be z. In the same way it can be understood. Okay, now next that one important concept is the position vector. That position vector matter is frequently used. Position vector. Okay, position vector. the position vector of point P is the vector, position vector of the point P is the vector OP with respect to the origin O. Okay, so the position vector of point P is the vector OP with respect to the origin. So if the origin of the vector is the origin of the coordinate axis, then that is called the position vector of the point P. Okay, that means its origin is fixed at the origin O, that is 0 0, and point P is fixed at the point P itself. So this is the position vector of the point P. Position vector of point P means vector OP. Position vector of point A is vector OA. Position vector of point B is vector OB. In this way, we can write the position vector of any point with respect to the origin. That means any coordinate gives us only the point, that is not the vector, but if we take the reference of the origin O, then that becomes vector. Okay, similarly, now if we have to find out x component and y component of any vector, let us see. Your origin x-axis, y-axis, suppose we have one point here, that is 1 2 1 2 and 1 2 3 4 5 1 2 3, and there is 5 3 is here, and let us join these 2 points. Now starting from here to reach this point and to go up, how much step right now, how much step up we have to go, let us see. So this is 1 2 3 4 step right, and it is 1 step up. That can also be obtained by 5 minus 1, it is 4. That means if this point is x1 y1, then its x component is, and this point is x2 y2, then this its x component of this vector suppose it is pq, is given by x2 minus x1, that is given by x2 minus x1. And here you can see it is 1 step up. Here 10 small division equals to 1 unit we have taken. It is 1 step up, that is 3 minus 2 also we will get 1. That means it is y2 minus y1. That means PQ, x component of PQ, x component of PQ equals to x2 minus x1, y component of vector PQ equals to y2 minus y1. In this way, we have x component and y component of vectors if there are 2 points p x1 y1 and q x2 y2 are given, then its x component is given by x2 minus y1 and y component is given by y2 minus y1. In this way, we can find out x component of the vector and y component of the vector. How much step right we have to go, that is x component. How much step right or left we have to go, that is x component. How much step up or down we have to go, that is the y component, starting from the vector's initial point. Okay, not of this origin, but starting point from the vector's initial point or till to reach to the head, how much step right or left we have to go, that is x component. And after going right or left, how much step up or down we have to go, that is the y component. Okay, in this way we can get x component and y component of the vector. Now next, that is the modulus of a vector. Modulus of a vector. So the modulus of vector is a positive number. The modulus of a vector, the modulus of a vector is a positive number which is the measure of the line segment representing that vector, Okay, so this modulus means actually the length. So length is always positive. Okay. Example, if there is vector OP equals to x comma y, then its magnitude, origin x-axis, y-axis. So here OP, it is xy, means it is x step right and y step up. Then its OP magnitude or length, it is denoted by OP and bar on this both sides. It is given by the Pythagoras theorem, p square plus b square. This is y square plus x square. So this is the magnitude of the vector. Okay, so this modulus of the vector or magnitude of the vector is denoted by OP. Magnitude of vector OP equals to OP and bar on both sides. It is also known as modulus of vector. Okay. In this way, modulus of vector is given by x component square plus y component square. Similarly, if vector OP equals to x, y, z, that is a space vector, then magnitude of OP or modulus of vector OP, that will be x square plus y square plus z square. Okay, hence magnitude of vector means x component square plus y component square if it is plane vector, or if it is a space vector, then magnitude of vector is given by x component square plus y component square plus z component square. In this way we can find out the magnitude of the vector or modulus of the vector. And this magnitude of the vector, as it is the length, it is always positive quantity. Okay, it is it resembles with the distance formula also. Okay, so if the x component is x2 minus x1, then x2 minus x1 square plus y2 minus y1 whole square. So this magnitude of the vector resembles with the distance formula of the coordinates as well. Okay, so in today's video that I discuss about some introduction about vectors and scalars. I hope that you found this video helpful. Thank you for watching, and if you have not already subscribed my channel, please subscribe my channel right now so that I will be encouraged to make more videos, and also press bell icon so that you will be informed about my coming videos. Thank you very much.